Lesson 2, topic, parallel lines and transversals. Learning target, I can use angles formed by parallel lines and transversals to solve problems. First off, a couple things from our resource sheet. We have corresponding angles postulate. So if two parallel lines are cut by a transversal, that means we know the lines are parallel. Then a consequence of that is that the corresponding angles are congruent or have the same measure. Alternate interior angle theorem. If two parallel lines are cut by a transversal, again we know that they're parallel, then our alternate interior angles are congruent, have that same measure. Similarly, we have our alternate exterior angles theorem. So if two parallel lines, we know they're parallel, cut by a transversal, our alternate exterior angles are congruent. And this is the one that's a little different, so we want to pay super close attention to it. Consecutive interior angles theorem. If two parallel lines are cut by a transversal, then our consecutive interior angles, so remember they're on the same side of the transversal, they are supplementary. And remember, supplementary means adds to 180. All right. So those are our theorems, and if you did the Unit 3 intro activity, you might have discovered that already. But if not, we're going to talk about it. We're going to use these. So the measure of 3 of the numbered angles is 120. Identify the angles and explain your reasoning. So right now, we know that the lines are parallel, which means alternate exterior angles would be equal. So the alternate exterior to 120 would be angle 8. So I can say angle 8. The measure of angle 8 equals 120 degrees, excuse me. And that would be because of the alternate exterior angles theorem. I can also say that angle 4 is 120 degrees because vertical angles. Vertical angles congruence theorem. And then we can also say that the measure of angle 5 is 120 because they are in the same position, which makes them corresponding angles. So the measure of angle 5 is also equal to 120 degrees by the corresponding angles. And we need to remember that that one is a postulate, not a theorem. All right, next one, find the value of x in the diagram below. So if we look at what we're given in our diagram, we have parallel lines cut by a transversal. And we have a couple different angle measures. But we know that these two angles are going to sum to 180 because they are consecutive interior angles. So by the consecutive interior angles theorem, we know that the measure of angle 4 plus x plus 5 is going to equal 180 degrees. Well, the measure of angle 4 is going to be the same as that angle of 115 degrees because they are vertical angles. So I can replace the measure of angle 4 with 115 degrees plus x plus 5 equals 180 degrees. 115 plus 5 is 120, so x plus 120 equals 180. And I can subtract 120 on both sides by the subtraction property of equality, and x equals 60 degrees. All right, and let's do a proof. Like I said, we are going to always come back to our proofs. So we're going to prove that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. we're going to prove the alternate interior angles theorem, which means we will not use the alternate interior angles theorem in our proof. This theorem has been proven, which is why we can use it, and we're going to do the proof, which shows us why this is always true, why we can use that theorem. So we're given this diagram, and we're given that P is parallel to Q. So our two lines are parallel. We see that in the diagram. So that first statement we know is that our given. P is parallel to Q. And then we're told that angle 1 is congruent to angle 3. Well, if we look at that, why can we say that angle 1 is congruent to angle 3? Parallel lines cut by a transversal. Always look to see what kind of angles we have. Right there, those are corresponding angles. They're in that same position. They're in that bottom left position. So we can use the corresponding angles postulate, which tells us that corresponding angles are congruent if the two lines are parallel. Next, we have angle 3 is congruent to angle 2. Well, if we look at our diagram, why can we say that angle 3 is congruent to angle 2? So here's angle 3, and here's angle 2. You see how they make those V's they're back to back, they're connected, they're those vertical angles. And we know that vertical angles are congruent because of our vertical angles congruence theorem. And then lastly, we're saying that the angle 1 is congruent to angle 2. And why can we say that? Well, that comes from 2 and 3. Look at 2 and 3. Angle 1 is congruent to angle 3. And angle 2 is also congruent to angle 3. We got that crisscross going on. They're congruent to the same thing, which means we can say angle 1 is congruent to angle 2 by our transitive property of congruence. So then if angle 1 is congruent to angle 2, and we look up at our diagram, now we have shown that angle 1 is congruent to angle 2. Those are alternate interior angles, and that is why the alternate interior angles theorem exists and works out every time. This is your reason. So now that we've proven it, we can use it in future proofs and other items. That's all our notes for today. We can go ahead and move into our practice.